Some of you may remember that 1997-98 was a big El Nino, massive El Nino, one of the biggest in the 20th century, and the Indian monsoon didn't experience a drought, which is unusual, but then they said the Indian Ocean dipole saved us from the drought, but then came 2023-24 El Nino, which was also pretty big, and there was still no drought in 23-24, 23 monsoon either, but there was no IOD to be seen to explain it away. So this paper looks at that, says westward displacement of atmospheric east-west circulation ameliorated drought-induced conditions in Australia and India during the major 2023-24 and 97-98 El Nino events. So I'll just read through it again, just brief. Based on a compilation of widely available climate analysis products, we show evidence for a significant variation in the spatial pattern of the large-scale vertical zonal atmospheric circulation patterns across the equatorial Indo-Australian domain of the Eastern Hemisphere. During the major 2023-24 El Nino event, the region of large-scale subsidence and its associated teleconnection patterns that usually are centered across Indonesia or the maritime continent were displaced to the west over the equatorial Indian Ocean. In the record of El Nino events, with readily available online dynamical tropospheric fields, one source from 1947, the other from 1979, this has only been seen two other times during the strong 97-98 El Nino and the weaker 97-78 El Nino. These three events may well be consistent with internal variability, but at present the reason for such occurrences has not been established. So that's the main message, that El Nino teleconnection is not always consistent over the Indian Australian monsoon regions. This is kind of known because if you look at the wet and dry years, only about 60% of them are explained by El Nino and La Nina in terms of deficit and excess years, and this is a debate, and yet monsoon predictions tend to rely a lot on El Nino because El Nino is predicted fairly reliably, especially in 23. It was predicted as early as March, April. During the spring season, there is always the spring predictability barrier, and we are not always sure whether the El Nino will continue to grow or not, but it turned out to be a very good prediction. On the other hand, 24 was a bust because an La Nina was predicted, which didn't really come true, right? So we have to always worry about these things, but given all this, just the main message here is that there are some patterns of shifts in the zonal cells, Walker cell, which is of course the biggest signal in the atmosphere during an El Nino. There is a Bieknis feedback, and ocean has a lot of changes in upwelling and SST anomalies, redistribution of convection, rainfall, across the globe, in fact. So keeping all that in mind, let's just read the introduction. There has been considerable media concern and public consternation that seasonal forecasts of a strong El Nino in 2023-24 fail to result in the suppression of rainfall and expected wider climate impacts in two major regions, often influenced strongly by the phenomenon, Australia and India. And India Meteorological Department had surprisingly made normal monsoon prediction, even though many other centers were calling for a drought. So IMD turned out to be right in this case. The reason for this has begun to be explored in scientific papers such as Tozer et al., while Wittenberg showed that intrinsic variability of ENSO can change substantially from decade to decade, and that internal variability can play a strong role in how events and episodes are manifest. So each ENSO is different, and the connections can be different, and then you have other modes like the Indian Ocean dipole or the Atlantic Nino, which also do some funny things that can cancel an El Nino effect and so on and so forth. It's well known that La Nina and El Nino events that usually last around 12 to 18 months, are the two phases of the El Nino Southern Oscillation phenomenon, cold, warm and cold phases, or cold and warm phases, La Nina and El Nino, centered in the Indo-Pacific basin, and so is a large-scale ocean-atmosphere interaction that varies in its onset, duration, magnitude, decay, and spatial structure. Basically, those are the basics that I have discussed elsewhere as well. Although El Nino and La Nina events produce more or less opposite impacts across and around the Indo-Pacific basin, no two events are exactly the same. This is also true for protracted El Nino and La Nina episodes, which can last for several years. Well, the El Nino of 2014-15 existed into one mild and one strong event, and 2018 to 20 had a La Nina. Well, they are calling it 2018 to 2020 El Nino, and 2020 to 2023 La Nina. Wow. La Ninas are clearly shown to last long, but El Nino has difficulties in qualifying as an El Nino based on how long the anomalies have to persist and so on. And there are process differences also between why El Ninos are different than La Ninas in terms of how long they last. So let's not go there, but nonetheless, the phenomena embraces a family of events and longer episodes whose atmospheric perturbations and resulting teleconnections carry its influences and physical impacts across the Indo-Pacific domain and to higher latitudes in both hemispheres, of course, all the way into South America, Africa, and so on, also into the Arctic and Antarctic. Okay, so that's the basic of what you expect during El Nino. You shift the convection from the West Pacific to Central Eastern Pacific, depending on which flavor of El Nino it is, and then you have anomalous subsidence over here, droughts, dust storms, wildfires, and then you have anomalous convection here over East Africa, and you have a signal on the Atlantic as well. So you can see the SST anomalies, warm anomalies. This is the canonical cold tongue El Nino, but you can have other flavors where the warming is centered over the date line, and then the convection shifts are different and the teleconnections are different. On the other hand, La Nina conditions have colder than normal anomalies in SST. The convection is shifted a little bit to the west, and heavier rains over here, drier conditions over here, and shifts in the Walker cell as well, which we have discussed in detail elsewhere. What happened in 2023? So you are looking at the 200 hectopascal velocity potential anomalies and the associated SST anomalies during January, February, March in the early beginnings, but you can see the SST anomalies may be beginning to appear here in the coastal regions. If you look at different the same things for different seasons, April, May, June, July, August, September, October, November, December, by April, May, June, the signature of El Nino was already there, but the opposite anomaly here in terms of cold SSTs that we expected did not happen, and you can see it never really materialized much either all the way into peak El Nino either. There is a dipole-like thing here, but not quite as strong as 97, 98. On the other hand, Ashok Karumuri and we had argued in a paper that this pattern during spring, summer may be the manifestation of global warming superposing on El Nino, so you have a tropical warm signal which is unusual also here. So the cold anomaly that we expect in a canonical pattern doesn't happen. Whether that has something to do with the westward shift and the missing droughts over India and Australia have to be seen, but this is another one showing the Hofmüller diagram. So you're starting here in spring of 2023 and going into the spring of 2024, and you are looking at time longitude Hofmüller section of anomalous pentad a 200 hectopascal velocity potential, average between 5 north, 5 south, which is the deep tropics where El Nino is very active. So this is for 23-24. Dashed contours indicate negative anomalies. Anomalies are departures from the anomalies are departures from the 91-2020 base period in pentad means and so on. But basically the argument is that the entire system was shifted westward in terms of where the subsidence and so on should happen. So instead of happening here, if it gets slightly shifted westward, then the local Hadley cell in both cases, it's different seasons, but and the monsoon anomalies can be different as well. Okay, so here is the maritime continent latitude, and here is the central Indian Ocean. Okay, so what are the comparisons with the 97-98 El Nino event? During the 97-98 event described by Slingo and Annamalai as the El Nino of the century, this displacement in the Indo-Pacific east-west zonal overturning cells is again most evident in the spatial patterns of the seasonal 200 hectopascal velocity potential anomalies that we looked at here. I'm only showing you one of them. Wong and Hendon also refer to this feature of the circulation pattern in 97 when they contrast it to the weaker 2002 El Nino event. In 1997, Australian rainfall was only severely reduced over southern and eastern Victoria, while the 97 Indian summer monsoon rainfall was around normal to slightly above average despite the strongest El Nino of the century. The 1997 pattern is also reported in Chowdhury and Pal, who compared and contrasted the circulation structures of the strong 82-83 and 97-98 El Nino events using time longitude Haumüller diagrams of anomalies of OLR and mean sea level pressures between 60 east and 80 west, so basically the entire Indo-Pacific stretch. They highlighted that the westward displacement of these features in the Indo-Australian sector is only observed in 1997. However, in contrast with the 2023-24 El Nino event, which I didn't show, the 97-98 off equatorial SST anomalies in both hemispheres are dominated by cold anomalies. So I don't show all those. Basically, you can see that here that the canonical pattern did play out in the 97-98 event, but the warming since may be interfering with the El Nino, at least in the sense of the anomaly patterns on the western part of the Pacific and over the maritime continent. But obviously one has to see whether that's related to the displacement of the anomalous subsidence and ascent or the Walker cell that we are talking about here. So I'll just jump to conclusions. It's a nice paper. I just wanted to make the main point that the El Nino monsoon teleconnections, and this is also seen over parts of California. Winter precipitation during El Nino should be very high over California, but that's not how it played out in 2015 either. And there is a paper, I think, by Shangping Shi's group talking about the change in the El Nino teleconnections over that region. We have shown that the major 97, 98 and 23, 24 El Nino events were characterized by a similar westward displacement of the center of large-scale equatorial subsidence from across the Indonesian or maritime continent region out toward the equatorial Indian Ocean. This profoundly changed the teleconnection patterns associated with these two events, such that the usual suppression of rainfall with extensive drought in Australia and India during strong El Nino events was not experienced. Beyond those regions, the climate impacts were much as expected during a strong El Nino event. Remember, there is a seasonality to these things as well, because the winter teleconnections over California probably will be differently affected than the summer anomalies during an El Nino. El Nino, of course, peaks in December, January, February. The major 97, 98, 23, 24, and weaker 77, 78 El Nino events were the only instances of westward displacement of the Indo-Pacific atmospheric east-west zonal overturning cells in the period available on line velocity potential fields dating back to 1947 and 1979 respectively. So I just said that global warming may be beginning to interfere now since the 90s, but 1976-77 was a regime shift that is seen as a jump from La Nina dominated periods into a El Nino dominated periods, with a very nice signature in the ocean thermocline in the deep tropics of the Pacific, but also in the Atlantic and so on. So whether that also was similar in its impact on the Walker cell perturbation during the 77-78 El Nino has to be looked at. Nevertheless, it should be noted that several papers have speculated about the role that an anthropogenically driven factors may have played about the role that anthropogenically driven factors may have played and will play in the future in shaping the nature and characteristics of ENSO events themselves and their relationship to various climatic features such as the monsoon systems. And there are many other papers that talk about this. The future availability of velocity potential fields in historical analysis such as the 20th century reanalysis that extends back to 1806 should present a long record with which to investigate these atmospheric east-west zonal overturning cells for any other occurrences of westward displacements during strong El Nino or La Nina events. So we are saying two things, that the internal variability of the El Nino itself and the tropical system in general can create a westward displacement of the subsiding cell and affect the monsoon signatures of El Nino, but global warming may load the dice in terms of making this maybe more frequent than in internal variability. Right? So good possibilities, but at least the record is clear that the Indian monsoon and the Australian monsoon didn't experience extensive droughts during strong El Nino events, despite the events, having raised the expectation of droughts. And 77-78 there were no predictions, but 97-98 and 23-24 were being closely watched and forecasted, and obviously monsoon forecasts in 23-24 turned out to be basically correct in terms of ignoring the El Nino that was obviously growing and still calling for a normal El Nino. And people made a lot of noise that was related to an election and that IMD was making a political call and so on. But in the end, IMD turned out to be right. So it's complicated how these things play out in reality, but the science is still very interesting that we have to follow up with. Okay, so I will leave this here.